Thank you for joining today. My name is Maria Terzi. I'm the WWCode Leadership Fellow for the Emerging Tech track. And today we have with us Esther Okafor for the webinar Introducing Software Testing in Blockchain Projects. Esther, you can now share your screen and start your presentation.
Okay, thank you, Maria, for the introduction. So I would share my screen now. Just give me a moment. Okay. Can you see my screen? Okay. Can you guys see my screen?
Yes, that's perfect.
Yeah, thank you. So thank you for having me today. Maria already introduced me. My name is Esther Okafor. I live in Nigeria, and the weather in Nigeria today is hot, but it looks like it wants to rain. But yeah, I just hope it doesn't rain. It rains after the webinar. So I would be talking about introducing software testing in blockchain projects, and the focus area for this presentation would be what is software testing, what is blockchain, how blockchain works, what is the need for testing a blockchain, the types of blockchain testing, the tools for blockchain testing, and how to develop a career in blockchain testing. At least that's the interesting part, because after learning, you will want to know the career path or what you can do to start a career in testing blockchain applications. So let's start with what is software testing. So software testing is a way to assess the quality of a software and to reduce the risks of software failure in operation. So examples of software are business application and customer products. So this is the generic definition of what software testing is, right? But today we're going to be looking at, software testing in blockchain projects. So software testing is an activity where, someone is trying to look for defects or look for bugs in an application, just to make sure that the application is working as it is supposed to work. For example, we have a banking application that is supposed to, where users are supposed to be able to withdraw, or users are supposed to be able to make payments. So we need to test the application to make sure users are actually able to withdraw and their money are also safe on the application. So yeah, generally that's the whole idea of software testing and software to check for failures. So now let's move to blockchain. So a blockchain is the simple way of explaining blockchain is a secure way of storing data. So here I have a blockchain is a digital database that stores record in chronological order. Information on the blockchain is kept in blocks linked to one another on a chain through mathematical algorithms. At its core, blockchain operates as a series of interconnected blocks, each containing encrypted data. These blocks form a continuously expanding chain storing data in a secure and immutable manner. So I know a lot of us understands what blockchain is, because this is a blockchain community, but I just thought of putting this explanation here of what blockchain is. So I would use baking a cake as a blockchain, right? So if you want to bake a cake, you need to have ingredients. let's say the ingredients in this case are transactions in a blockchain, right? The ingredients for baking a cake would include sugar, flour, eggs, and stuff like that. And then the process of mixing, the steps of mixing this ingredient together would be like the blocks in the blockchain, right? And then the cake itself is the blockchain, right? If for example, we finish baking the cake and then we're trying to like, we now want to like say, okay, we want to remove sugar from this cake. It's not going to be possible because you want to remove sugar means you want to like destroy the cake and, you know, bake another cake. So this is just to explain how secure the blockchain is, right? You can't just remove data from the blockchain and put in data. So it is blocks that are connected with chains. So the next thing is, how does blockchain work? Understanding the fundamental principle of blockchain begins with a structure. Every block within the blockchain holds its distinct hash value along with the hash value of the preceding block it is linked to. Originally, blockchain was created for digital money like Bitcoin, but currently, blockchain is now used in different industries, like the health industry, like the creative industry. We now have things like NFTs, right? Where, you know, creators can now own what they have, right? So yeah, I have this diagram here. In this diagram, we have block 1, block 2, block 3, and then we have things like chains linked to this block. You can see the previous hash of this block. We have like 0, 0, we have like 0, 0, 0, and then we have another hash. So if the hash is not correct, right? So the block 2 is supposed to like reject whatever is coming from the block 1 if the hash is not correct, and then it's going to the block 2. So this is what makes the blockchain secure. Each value is unique to a block. You can't just like change any records. So before you move a value to the next block, there have to be like some verification or validation to check that the hash is correct, the hash value is correct before it is moved to the next block. So yeah, the next thing I have here is, what is the need for blockchain testing, which is the whole essence of this webinar. So when a blockchain is implemented into a software product or application, why do we test it? So now, why do we do software testing? Like I said in the first slide, software testing is an activity that we use to verify that a product is working as it is supposed to work, right? So the same thing for blockchain testing. Why do we test blockchain? We test to make sure that it is working as expected. So blockchain testing involves the comprehensive assessment and validation of blockchain-driven application or system. It involves a meticulous examination to ensure the smooth operation of performance, security, and reliability of the blockchain network. So the primary goal is to identify, address, and resolve any potential issues or vulnerability, ensuring that the blockchain functions as intended and aligns with the specified requirements. So basically, we are verifying the functionality the performance, security, and reliability of a blockchain-based application system. So yeah, that is why we need to test the blockchain to verify to verify the functionality, to verify the performance, to verify the security, to verify the reliability, because the whole essence of blockchain is for it to be secure, right? So testing blockchain is actually very important because we want to make sure that it is actually secure and anonymous for each user on the system. So we have, types of blockchain testing. So in a blockchain network, there are many computers called nodes. So each node keeps a copy of all the transactions that ever happened on the blockchain. So when a new transaction occurs, all these nodes work together to confirm and record it. I gave an example in the diagram of the sample 3 blocks, right? So if each block has a hash value and then a previous hash value, if before the block 1 is sending a value to the block 2, it has to like verify and validate the value to make sure it is correct and is coming from the correct block, right? So yeah, for instance, imagine a group of friends sharing a journal. Whenever someone writes a new entry, everyone in the group of friends must agree that that entry is valid before it gets added to the journal. So similarly, in a blockchain, all the nodes need to agree that a transaction is valid before it becomes a permanent part of the record. I use baking a cake as a blockchain. So imagine one of the ingredients of baking a cake being petrol, right? We all know that petrol petrol cannot be used to bake a cake. And someone comes and say, oh, we need to add petrol to the ingredients that we're using to bake the cake, right? So petrol is not valid, so we cannot add petrol. So every node in the blockchain need to agree before the transaction becomes part of the record of that blockchain. We have flour, we have sugar, we have eggs. Those transactions, those are like transactions in the blockchain that agree. And then we can mix those ingredients and then it becomes a cake, right? So when something external is coming in and we're trying to mix, you say, no, this is not supposed to be a part. So yeah, that is what it is there. And because there are many different computers which are nodes involved in this process, it is crucial to use strong security methods to keep the information they share, right? Just like using a secret code among the friends to keep their journal entries safe from anyone who shouldn't see them, right? So the example of the friend sharing a journal, for security, they need to have like a secret code where nobody else has that code except them, and that is what they use to access their journal. So in summary, in a blockchain network, all the computers work together to verify and record transactions securely, ensuring that the information added to the blockchain is reliable and cannot be tampered with easily. I think that's one of the strong areas of Web3, which is that it should be secure, right? That's like the major thing, the security of the blockchain network is what makes it very unique from every other database. So the first types of testing we have here is the functional testing. Just like the generic testing, I don't know if we have software testers in the webinar, but you have come across functional testing and different type of testing, manual automation, and all of that. So in blockchain, we have functional testing. So the things you can test, the functional tests you can make on a blockchain network would be testing the block size. So in a blockchain, each block has a memory size, right? So if for some reason the transaction that is meant to stay on that block need not exceed 1 megabyte or 2 megabytes and stuff like that. So this is one of the testing that you can do to make sure that the block is able to take the megabyte size it is supposed to take. So if a block is supposed to take a transaction of 1 megabyte, right? It should be able to take 1 megabyte and not take maybe 50 kilobytes or less, or above 1 megabyte, maybe 2 megabytes and stuff like that. So we need to check for that too. Like for example, I have here, I said, so software testers should focus on scenarios like transaction data stored in each block exceeding 1 MB, encryption techniques used to connect the blocks, right? So we need to check for things like that. And also, we also need to check for data transmission, right? The main architecture of the blockchain revolves around data transaction and security. So the first thing we want to test is there a possibility that we can lose data during this transmission? So if a transaction is moving from one block to another, we need to check that no data is lost in the process and every data is moved from one block to another accordingly, right? So the next one is block addition. So we need to carefully evaluate the blocks added to the chain. The reason is once a block is added to a chain, it cannot be altered. Just like I said, once you mix your sugar and everything using to bake your cake, when you finish baking your cake, you can't say you want to remove only the sugar from the cake. It's not possible. Because if you want to do that, that means you want to spoil the cake. So this is one of the reasons why you need to test each block addition to make sure that they are correct. Because once a block is added, you cannot just remove that block from the chain. So the next things are smart contracts, right? So smart contracts are basically rules written by blockchain developers that needs to be followed. So we need to make sure that every party is involved in transaction are adhering to the rules of the smart contract, right? For if, I don't know if anybody here do crypto, Bitcoin, and all of that, there are some rules that have been written that you cannot, that whoever is using the blockchain cannot like bypass those rules. You need to strictly adhere to the rules, right? So that would ensure that the app is functioning the way it is supposed to function. So the next thing is node testing, right? We need to test all the nodes present in the blockchain. So testing this is important because it will ensure that it is functioning, the blockchain app is functioning properly. So the next type of testing is integration testing. And basically this integration testing is mostly connected to APIs, right? So integration testing in blockchain involves examining the connection between different components and thoroughly testing the APIs associated with these components to guarantee the compatibility and smooth operation, ensuring the reliability of the blockchain system. So if you know what APIs are, so these are what the application is talking to. So this webinar is quite, theory, but maybe the next one I would like do a little presentation on some blockchain APIs. So for example, we have APIs for getting all the blocks, APIs for posting a transaction on the blockchain network, and APIs for different things. So we need to test this API to make sure that they are communicating well, right? So this integration testing is basically checking like the compatibility of these APIs on the blockchain system. So if I'm calling this API, is it responding with the correct response? There are various things you can check on the API. You can check the status code, you can check the JSON response, you can check the key and the value from the API response. You can check a lot of things, right? So this is one of the types of tests that you can do on the blockchain. So the next one is the security testing. Like I said, the major usefulness of the blockchain network is its security. So security testing in blockchain is a comprehensive process that examines various layers of security, ranging from the user authentication to data encryption and resilience against potential attacks, right? When we talk about the user authentication, let's say, for example, you have a Bitcoin wallet, and this wallet has like some set of codes that you need to use to be able to access the wallet, right? So the code is like your authentication to access the wallet. So only you has that code. We need to when testing, we need to make sure that the wallet can only be accessed with that code and no other code, right? So that is where the security comes in, making sure that, every block is using its unique hash value, and when the hash value is moving to the next block, it is correct, and the block is not just accepting a hash value that is incorrect. So the primary goal of the security testing is to assess the vulnerability of the blockchain application against potential attack. So it is to ensure the credibility of the blockchain network, to make sure that it is accessed by only users who have the exact, authentication key to them. So yeah, that's it for security testing. So for performance testing, so performance testing ensures that the blockchain system can manage different transaction volumes, maintain speed and responsiveness across various networks conditions, providing an efficient and reliable user experience. Let's take, for example, Coinbase system. Coinbase is an example of a Web3 company that uses the blockchain the blockchain, because the blockchain is decentralized and they use it for their wallets, for Bitcoin and their crypto and stuff like that. So Coinbase, when they want to push out their application, they need to test that if we push out this application, can we have like 100 signups in 5 minutes and the application will not crash, right? So this is where the performance of the system comes in. They need to make sure that their system is able to manage that capacity. If, for example, we have like 200 users trying to withdraw from their crypto wallets in 1 minute, would they be able to do that? So those are the things they would like check for as part of their performance testing. Yeah, I said, for instance, in testing a blockchain-based financial system, the performance testing might involve evaluating how well the system handles a high number of financial transactions, measures the time taken to process each transaction, and ensures that smart contracts execute transactions swiftly and accurately. We've spoken about smart contracts, right? So basically, the performance testing is to check for this. And I have some things here. I have checking for the transaction volume and size, checking for the network performance, like checking for the transaction processing speed, your user interface and system interface, checking that the system responsiveness and usability for users and backend operations. Can our users use this app? Our buttons, when I click on a button, does it respond immediately or does it take time to respond? And then smart contract responses, verifying the speed and accuracy of smart contract execution in response to different inputs and conditions. So yeah, basically that is, the types of blockchain testing that we have. I mentioned performance testing, security testing, integration testing, and functional testing. So those are the important testing that we need to do on a blockchain application. So we have some tools that helps. We have the Ethereum tester, we have the Hyperledger Composer. These tools are available, so you can check them out on Google. You can also try to use them. Bitcoin J, Populous, Manticore, Embark Framework, and Truffle. Truffle is very, very, very common. And they have like, I think they have like a playground when you search on Truffle on Google, where you can see some example of how to test smart contracts on a blockchain network. So yeah, so basically these are the tools that I was able to like put together that you can use to test blockchain applications. And we move to the interesting part, which is navigating the path to a career in blockchain testing. So after this course, introducing software testing in blockchain projects, you might want to understand how to like build that testing skill in you if you want to focus on testing blockchain or Web3. The first thing I have here is understanding the blockchain fundamentals. So you need to understand the basics of the blockchain network, things like what what the blockchain means, what are smart contracts, and what are the technologies used in writing blockchain codes and stuff like that. And the next one is acquiring technical skills. You need to actually learn how to write programming language like Solidity, which is used for Ethereum, C++ for Bitcoin, or JavaScript. Yes, you need to understand React JS to be able to like be a software test engineer in blockchain. And then you need to understand testing methodologies. For example, I talked about functional, performance, and security. So you need to understand these things because when you're giving a blockchain application to test, the first thing is you need to think about what am I going to test in this application, right? So it is important that you understand this methodology so it doesn't look strange when you find yourself in a position as a blockchain tester. And then you need to network and collaborate for like engage in online forums, conferences, hackathons to connect with industry professionals within the blockchain network. So this is very important for opportunities. If you're trying to like be a blockchain tester, it is important that you network and collaborate so that you can meet people who can help you, maybe introduce you to companies where you can get jobs or internships or any other thing that you want, or maybe you might want to be a speaker for a blockchain conference. So yeah, it is good to network and collaborate. And then also you need to be certified. It is not 100% necessary, but it is good that you obtain certification in blockchain. We have like the Certified Blockchain Tester certification, Certified Blockchain Security Professional. These things are necessary to validate your skills and dedication in the field. This is just to show that you are, particular about the blockchain field and you want to become like an expertise in that field. So yeah. The next thing is the careers in blockchain testing. So the rise in demand for blockchain technology has opened up abundant career prospects for professionals specializing in blockchain testing. So some of the job roles includes blockchain test engineer, right? This one is blockchain test engineer is actually very, 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 very high level because you need to understand programming and how the Ethereum, Bitcoin, and all of those things work together. You need to, I said, involve in devising, creating, and implementing test scenario to ensure effectiveness, efficiency, and security of the blockchain application. So for blockchain test engineer, you need to understand how to write automated tests for different test scenarios in smart contracts and yeah. And then smart contract auditor focused on reviewing and validating accuracy, safety, and effectiveness of smart contracts. Like I said, smart contracts are like rules that need to be followed on the blockchain network, right? So there are people who are like dedicated to test these smart contracts to make sure that these rules are actually followed and they are not bypassed. So yeah, that's one of the careers that you can pursue. Another one is the performance tester, just like the regular performance testers that we have for the Web2 applications is the same for the Web3, because you're testing for load, you're testing for speed time, you're testing for transaction volumes, you're testing to break the system, you're stress testing the system to check that the performance is working as expected. The next one is the security analyst. So the security analyst will check for weaknesses and risks and vulnerabilities within the system. We mentioned checking for the user authentication, checking that codes are unique and people are not able to, get into the system using codes that are not meant for it and stuff like that. So yeah, I think this is it. Let me check. So yeah, and I think, yeah, now we are in the conclusion part, which is, blockchain technology is rapidly evolving and promising immense growth. We see it everywhere. I heard something they said in 2025, blockchain would be the Web3 would be the in thing in the tech industry. So if you want to pursue a career in blockchain testing, I think this is the right time to start, learning about it and start checking for those tools that I mentioned in the previous session, in the previous slide, and, start trying to learn and see if you can, get your hands on them. And yeah, I think that's it for this session. I don't know, I've been the one talking. Do we have like questions? Does anybody have?
Thank you, Esther, for the great presentation. I think we all learned a bit more about software testing blockchain projects today. We have a few questions from the
Can I stop
participants.
sharing my screen?
Yes.
Thank you.
So quite a few questions are on the process of software testing. Dolores is asking, what is the process for verifying transactions? Would evaluating a smart contract be an example?
Yeah. So that is actually an example of verifying. Like I said, smart contracts are like rules written in the blockchain network, right? So it could be like this, the rules could range from, users should not be able to withdraw a certain amount, or user should be able to withdraw over a certain amount. So yeah, that's actually what guides the transactions on the blockchain network, smart contract. So yeah, that's it.
Nice. And someone else is asking, how can we test the data transmission security? So when you have been talking about testing the security, you mentioned somewhere about data transmission. So how can we ensure that the data transmission is secured, let's say?
So I'm so sorry that I wasn't able to like do some practical stuff because I started preparing the slides quite late. That's why. But maybe the next session I might, come up with some APIs to test how these data are being transmitted from one block to another. So this could be now from one API to another, checking the key, checking the value, making sure that they are correct. For example, if I'm supposed to use a value, maybe a block value of 1, and the previous block value is 5, and then I'm coming with a block value of 2 and 6, which means that it is correct. It is incorrect, I mean. So the next block is supposed to throw an error to say this value is incorrect, right? So that's like one of the ways to check for data transmission in the blockchain network. So the value needs to be correct before it is moved to the next block, which ensures the, how am I going to put it? Which ensures that the data is accurate. Let me use the word accurate. It ensures accuracy of data on each block. So yeah.
I think this is clear, and I think it will be fantastic if we can have a follow-up event, a more practical one, where you can actually show us maybe using one of the tools that you have mentioned, some of the testings that we can carry out.
Yeah.
Funky and Elena are also asking, are both asking about the tools that you have displayed for testing. Are they open source and are they available for free?
Yeah, some of them are open source. Most of the Web3 stuffs are open source. There are a lot of, companies that made it open source so that people can learn, because they're trying to get people to learn Web3, right? So yeah, most of them are open source. I can paste them on the Slack, and then you can go check them out. Yeah.
That would be fantastic. And I'm sure people would also like to know in which language, what language they need to use for each software testing tool.
JavaScript.
Oh, is it
It's
on?
basic JavaScript. For
Okay.
example, Truffle is JavaScript. So if you understand JavaScript, you can be able to like test smart contracts on Truffle, because it's used the basic describe, it, and your normal JavaScript functions, and then you use your expect that this value brings out this value, expect that this outputs this, and things like that.
Perfect.
Yeah.
Joy says, thank you for the presentation. As a newbie to blockchain testing or testing as a whole, could you recommend some articles I could read on to help my understanding? So can you share some articles or some resources for people that are starting now in testing and in testing for blockchain?
Okay, so for that, I can check, and then I would share with you, and then you can share with them on the group.
Or we can just have it directly on Slack, on the WWCode emerging tech Slack, and everyone can see this information.
Yeah. Yeah.
Someone else is asking, I'm trying for software test roles. Could you please organize more sessions with testing focus in general? Would be great, not particular to blockchain, like software testing automation, API testing, Python automation, and performance testing. Of course, we should. And thank you for giving this request out. I think many people are interested in testing. And if you're a testing engineer or if you're just a developer, you always want to learn testing. I mean, in the big companies, the developers write the test themselves. So it's always useful to know more about this.
Yeah.
So I'm now sharing in the Slack all the links for joining the Slack community and our social media for everyone that want to get in contact with us. Thank you, everyone. If there are no other questions, I would like to thank you, Esther, for this very insightful presentation. We'll be waiting for your to share some information on Slack, on the testing tools, and if you can recommend any articles for people that are now starting out in testing and testing in blockchain. I would like to thank you for being with us today. There's another question. Can you please share the last message of links here in the Q&A? Yes, I can also put it here in the Q&A. Here you go. So thank you everyone for joining us today. It has been a pleasure. Thank you, Esther, again for your presentation and for taking the time. And I really look forward to a follow-up event. I think all the participants agree that it will be very interesting to have a workshop on this where you can show us a more hands-on example and a practical session for software testing in blockchain.
Yeah.
Thank you, everyone. Have a great day, night, or afternoon ahead. Thank you, Esther.
Yeah. Thank you very much. Bye, everyone.
Bye.